Most years, students fail this question in chemistry exam. You that you're preparing for WAEC this year, did you notice this question in past chemistry exam question? And you do not ask yourself why this question always WAEC repeat. The answer to this question is because most students fail the question. Today I'm here to explain this particular question to you step by step. I'm going to solve this question in less than 10 minutes. We have about 8 steps in this question. Let me go ahead and read the question. The question says a compound contains 40.0% carbon, 6.7% hydrogen, and 53.0% oxygen by mass. The relative molecular mass of the compound is 60 grams per mole. A. Determine the empirical formula of the compound. B. Determine the molecular formula of the compound. C. You have to state the name of the compound. And then D. You have to draw the structural formula of the compound. Now, after reading the question, the first thing, most students, they don't actually know how to write in exam. And you fail exam not because you are not good enough to write the exam, but because you lack the steps and because you lack the easy steps for you to follow in order to match with WAEC marking scheme. So today, I'm giving you the simplest step, also the same step that WAEC used in their marking scheme. Now, first of all, whenever you see a question like this, what will actually come in your mind first? The first thing that you will do is thinking or knowing where this question is set from. That is the topic that this question is set from. Now, to our question here, this question is set from empirical formula and molecular formula. Now, after knowing where the question is being set, the next thing is for you to bring out your data. So I advise you that mostly whenever you see a calculation question like this, what you will do after knowing the topic, the next thing is for you to bring out your data in the question. So our data in this question here are, we have carbon is equal to 40.0%. We have hydrogen is equal to 6.7%, and then we have oxygen is equal to 53.0%, and lastly we have the molecular mass, and our molecular mass here is equal to 60 grams per mole. After solving this question, I'm going to give you the shortcut, the proof that you can actually know that your answer of this question is correct. So let's go ahead. After bringing out our data, the next thing we'll do is for us to look at our steps. So our steps here, we have step 1. This is our first step. So in step 1, now the first thing you will do in this question is for you to convert the percent, to gram. So assume 100 gram of the compound. Now the next thing, now after when you assume, okay, let's see our elements here, their values in percent, so we have to convert it to what? To gram. Convert percent to grams. Now we have carbon, which is 40.0. Instead of percent, now you now put grams. The next element there is hydrogen, and hydrogen is 6.7. Instead of percent, we now have grams. The last element here is oxygen, and oxygen is 53.0. So we now have grams. Okay, I want to say something here a little bit. In this particular step, this is where mostly students get it wrong and they lose more of their marks. And once, if you do not convert your values to gram, now it will tell the examiner that you don't know actually what you are doing. That's where mostly students, they lose most of their marks because they do not convert it to grams, and then they go ahead by calculating their values. So after getting this step, you are good to go. You have about 2 marks in these steps. So the next step, we are to look at step 2. Now in this step, this is step 2. After when we convert our values to grams, the next step is to convert mass to moles. Now, mass to moles. So in this step now, we are converting mass to moles because we have already succeeded in converting percent to grams. So now we are converting mass to moles. So the value of carbon, let's start with carbon. The value of carbon that we converted is 40.0 gram, and the value of our hydrogen is equal to 6.7 gram, and the value of our oxygen is equal to 53.0 gram. Now, in converting mass to molar mass, the formula for converting mass to moles, the formula to convert mass to moles is moles is equal to mass divided by molar mass. So now we have the mass of carbon here, but we don't have the molar mass of carbon. Now the molar mass of carbon is 12, so we have to divide grams by molar mass. So 40.0 divided by 12, that's our molar mass. And for hydrogen we do the same. So we have 6.7 gram divided by 1, and 1 is the molar mass of hydrogen. And the last element here, which is oxygen, and the molar mass of oxygen is 16. So we have 16, and this molar mass is measured in gram per mole. So let me put gram per mole so that we get everything correct. Gram per mole, gram per mole, per mole. So if you divide 40 by 12, it will give you 3.33. Now you see, gram will divide gram, so at the end you end up with what? Moles. So you have your mole, 3.33 mole. So the next is when you divide 6 this by 1, it will still give you 6.7 mole. And the last, which is oxygen here, when you divide 53.0 or divide by 16, it will give you 3.33 mole, because the grams will cancel each other. The grams will cancel each other. Then you're now left with a mole. So we have succeeded in getting our values in moles. So we are through with step 2. Our next step is step 3. So in step 3, what we are about doing in this step is to divide the values of our moles by the smallest number. So divide moles by the smallest number. So carbon is equal to 3.33 mole, and we have hydrogen is equal to 6.7 mole. We have oxygen is equal to 3.33 mole. Now in these values here, which value here is the smallest value? So 3.33 mole is our lowest value here. So we have to divide these values by 3.3. So we have divide by 3.3, divide by 3.3, divide by 3.33. So now if you press your calculator, 3.33 divided by 3.33, it will give you carbon is equal to 1, and then hydrogen is equal to 2. Then we have oxygen is equal to 1. So we are moving fast now. We are through with this step. This is step 3. Step 4, we are to write the empirical formula. Now in this step, from our step 3, where we have carbon is equal to 1 and hydrogen is equal to 2 and oxygen is equal to 1. So the empirical formula is CH2O. This is our empirical formula. So step 4, we have succeeded in getting our empirical formula. So the next step is step 5. Step 5. So now in step 5, what we are going to do here is for us to calculate the molecular mass of the empirical formula. So we are to calculate the empirical formula, the molecular mass. Now molecular mass of empirical formula. So the empirical formula here, we have CH2O, and the molar mass of carbon is 12 and hydrogen is 1, but we have 2 of hydrogen there, so we multiply by 2, and then oxygen is 16. So when you sum all this value together, you have 12 plus 2 plus 2, okay, 12 plus 2 plus 16. It will give you the sum total of 30. So this is the molecular mass of empirical formula, and the molecular mass of this compound here is 30. So the next step is step 6. Now our next step is step 6. Now this step now is one of the important vital step here, because after getting your step 4, step 5, now what you will do here is you are going back to divide the relative molecular mass by the empirical formula mass. So divide molecular mass of the compound by the empirical mass formula. So now you see that these steps is very simple to understand. So we are to divide the molecular mass of the compound by the empirical mass formula. The molecular mass of the compound is given, which is 60 gram per mole, and we have 30. So we divide 60 by 30. Now if we divide 60 by 30, will give us, this one is gram per mole too. So if we divide everything, will give us 2. We divide 60 by 30, will give us 2. So we are through with step 6. Step 7. Step 7. In this step, this is the step that we are to find our molecular formula. So molecular, write the formula, write the molecular formula of the compound. So in this step is a little bit difficult, but let me make it in such a way that it becomes simple to you guys. So now in this step we are to write the molecular formula of the compound. Now we have a value of 2 here, so we will get the molecular formula from multiplying we'll get it from multiplying our empirical formula by 2. So now let's multiply empirical formula empirical formula by 2. So what is our empirical formula? Our empirical formula that we calculated is we have CH2O. Let's put it in bracket. So you now multiply, you put 2 outside. So our molecular formula is equal to, when you multiply 2 by 1C, it will give you 2C. And when you multiply 2 times 2H will give you 4H. And then when you multiply 2 times 1 oxygen will give you 2 oxygen. So this is the formula of molecular formula in this question. The next step, which is step 8. Step 8. Now in this step we are to name this compound. Naming this compound is ethanoic acid. Ethanoic acid. This is the formula of ethanoic acid. So step 9, which is our last step. Our last step is step 9. So in this step we are to write the structural formula of our compound we get. So now we are to write the structure of this compound. So please, you watch very well, you watch carefully, because I'm going to draw the structural formula of this compound. So you have C, then you have a bond here bonded to hydrogen, and another bond here bonded to hydrogen here, and another bond bonded to hydrogen. So we have consumed 3 hydrogen. So you have 2C, you bring another C here, and this C here bonded with double bond to oxygen and a single bond to oxygen and hydrogen. So this is the structural formula of ethanoic acid. Let's count how many elements in the molecular formula and in the structural formula. We have 1, 2, 3, 4H, which we have 4H here. We have 1, 2, which is 2C, and then we have 1, 2, which is 2 hydrogen. So now, I said something earlier. I want to help you guys by proving whether the answer that we got by solving is actually correct. Now, what I want you guys to do is that whenever they give you a relative molecular mass, now this relative molecular mass is telling you, this value here is telling you that this is the actual molecular mass of the final answer you will get. And let me tell you one funny thing here. If your chemistry is good, you will know that yes, if I have 60 gram per mole of a relative molecular mass, it means my final answer is actually what they have given earlier in the questions. So right now what you will do is that, since you have 60, from your question, the compounds, the elements that make up that compound, which is carbon, hydrogen, and oxygen. Now, if you say, okay, carbon, the molar mass of carbon is 12, and then the molar mass of hydrogen is 1, and then the molar mass of oxygen is 16. Now, you can actually use your brain, and then you now say, okay, if I have 2 of carbon are here? If I have 2 of carbon, it means I have 24. And if I have 2 of oxygen here, it means I have 32. So if I add 32 with 24, it will give me what? It will actually give me 56. So after when getting 56, so how many value remains to reach 60? So if you subtract 56 from 60, it will remain 4. So that means our hydrogen is 4. So this is simple as it is. So always you need to be calculative. You need to reason. Science is all about logical reasoning. So we have come to the end of our lesson. If you found this lesson is helpful to you, please, if you have not subscribed to my channel, make sure you subscribe to my channel for more chemistry questions like this. I wish you success in your WAEC exam. See you in the next lesson.